Here in this video, we are solving three problems in fact, that appeared in NEET 2024 from the chapter Magnetism. In Magnetism, there is surprisingly 4 questions in this paper, or 2 are in the options of last 10 questions. Anyway, let us see the question. This is all about the term susceptibility. So first let me tell you back what do you mean by susceptibility. Shown with the letter psi is the measure of ability of a material, a magnetic material, to be converted into magnet. Means what? If a material has a high susceptibility, it becomes a strong magnet, and vice versa. So from this it is very clear that susceptibility 0 means it's a non-magnetic material. So for a D, it has to be 1. There is no other options, right? So D4 is wrong. D1, this is one possible answer. This is also one possible answer. Correct, possibly. Ferromagnetic is the strongest material among all the materials. So its susceptibility is the highest, much greater than that of the 1. So for B, it has to be 3. Fortunately or unfortunately, for both of them, B is 3. So we cannot rule out anything. Then diamagnetic is the material, they are slightly repelled by the magnets. They move against the magnetic field. That means their values are in negative. Susceptibility is in negative. See here, it's greater than 0, but it is close to -1 is also quite possible. Therefore, for A, it has to be 2. Here A is 2, but here A is 4. So this can be ruled out. And it can be further said that paramagnetic material who has a susceptibility but not as big as this ferromagnetic material. So that is in between small positive number. So this is correct. So for C, that is going to be option 4. So this option, the first option, is the right answer for that. So that's a simple theoretical question. Let's have a look at the next question. This question says, in a uniform magnetic field of B given for you, let's write down what's the data given for you. Magnetic field strength is 0.049 Tesla or 49 into 10 power minus 3 or 4.9. As I have divided with 10, I have to multiply with 10. That is 4.9 into 10 power minus 2 Tesla. Performs 20 oscillations in 5 seconds. So frequency is the number of oscillations per second. That means 20 by 5. That is 4 Hz. If frequency is 5, time period will be 1 by 4. That means it takes 1 by 4 seconds to complete one oscillation. The moment of inertia is further given for you, I, as 9.8 into 10 power minus 6 kilogram meter square. What is the magnitude of magnetic moment? That's the question asked. We can write time period of a loaded spring is 2 pi into root of I by mbh or mb. B is given for you. So only m is unknown, everything else is known. Just I need to substitute the data. Time period is 1 by 4, 2 pi into root of I means 9.8 into 10 power minus 6. M we have to find out. B is 4.9 into 10 power minus 2. 4.9 is twice. Minus 2 gets cancelled and minus 4 will remain. Yeah. So if I simplify this further, what is remaining is 1 by 4 equal to 2 pi into square root of 2 into 10 power minus 4 by m. Everything else got cancelled. Let us square this equation. 1 by 16 equal to 4 pi square into 2 into 10 power minus 4 by m. That implies m equal to 4 pi square into 2 into 10 power minus 4 into 16. I have just cross multiplied them. Yeah. Then what we can say is 16 fours are 64, 64 twos are 128. Pi square into 10 power minus 4 is the answer I have. But he wants the answer in terms of 10 power minus 5. To get the 10 power minus 5, I shall divide with the 10. So to compensate that, I shall multiply with the 10. So 128 pi square into 10 and by 10, and the unit is ampere meter square. So magnetic moment is 1280 pi square into 10 power minus 5 is actually given in the question itself. So that won't be appearing in the answers. So 1280 pi square is the answer for the problem. That's how we solve this problem. And there is of course another small question. Let us see that another small question. It is also a NEET 2024 question. 2024 NEET question. The same paper. The question is like this. An iron bar of length L has a magnetic moment M. This is the iron bar whose length is L. That means from the center this is L by 2, this is L by 2. This is the north pole, this is the south pole of identical pole strengths. Whose magnetic moment capital M equal to small m into L. That was given for you. Now it was bent at the middle such that angle, it's here, it makes an angle 60 degree. So it was bent at the middle. This is how it was now bent. This is L by 2. This is L by 2. Here the angle is 60 degree. This is north pole, this is south pole. Because this angle is 60, this is L by 2 and this is L by 2. This is an equilateral triangle. And this length is also L by 2. So pole strengths are, so new magnetic moment of the system is, pole strength remains same even after bending. Distance between two poles is now this one, L by 2. M into capital is original magnetic moment by 2. So M by 2 is the answer for the problem. This is how we can solve all the questions that appeared in NEET 2024. Thank you for watching.